Hello, I'm going to record a video that I think might help some of you with unit conversions. I'm not going to actually sit and practice the unit conversions. I can do that too, but one of the things you'll discover about me as a teacher as you get to know me is that a lot of times when you're having trouble with something, I'll back up to something that's different but similar and make sure that you understand that first. And so what I really want to talk about here is the idea of like standard notation and place value. There we go. And the idea of expanded form. So again, you're not going to see a homework question like this, but the last time I taught this course, I actually did this for a few minutes with them, and it seemed to help some people with the concept. And then I basically made up a couple and had them do them. The camera's jumping in and out of autofocus or something. All right. So what I really want to do to get you thinking about some elementary school math that you largely just do now on autopilot. I'm just going to make up a number, 5,248.67. I want all the digits to be different for this time to make it obvious. So one of the things you might think about here is, what does this number even really mean? Well, it means 5,000 plus 200 plus 40 plus 8 plus 0.6 plus 0.07. And so that's called expanded form because obviously it takes up so much more space. And it's thinking about it like the number from a place value perspective. This is the thousands place is 5. The tenths place is 6. And so maybe you've made it that far, but one of the things you could kind of do is keep going. And so some of you might have even seen this, but it's probably been a while. Well, this first part is really 5 times 1,000. And this second part is really 2 times 100. And this part here is really 4 times 10. And this part is 8 times 1. And this part is 6 times 0.1 or a 10. And this part here is 7 times 100th or 7 times 0.01. And so then now it's okay, you're making it clear that you understand place value, Mr. Carpenter. I'm not sure how this is helpful or what the point is. And then I'm going to transition and I'm going to say, okay, well, here's the part that takes it yet another step, even more extra, that you probably never necessarily had to do, because by the time you start talking about exponents, you were probably already decent at thinking about numbers this way. So your teachers never bothered to necessarily have you do exponent form. And again, it gets back into the idea of place value and the fact that we use what's called a base 10 number system, which number systems will actually be one of the last things we talk about in the class. So really what's going on here is that this is 5 times 10 to the third power, and this is 2 times 10 to the second power, and this is 4 times 10 to the first power. And, the idea of a base 10 place value system is that every digit is a multiplier, and the base of the exponential piece is 10. That's why it's base 10. And then this is the exponent. And so this gets also into our prefixes of like kilo is 10 to the third is 1,000. And what you might not remember very well, and why I say that you probably didn't see this last part in elementary school, is that 1 is actually 10 to the 0 power, and 0.1 or 1/10 is actually, sorry, it wasn't an 8, it was a 6, times 10 to the negative 1 power. And so, like, you never necessarily saw this because you probably didn't see negative powers until high school. And by high school, you're not necessarily thinking about breaking this number apart into all of its pieces. And then the 7/100ths would be plus 7 times 10 to the negative second power. And so that's like a fully expanded form using power of 10 notation. And it's just really a complicated way of writing this number that didn't seem that bad, honestly, for most of us. But it forces us to actively think about the idea of place value. Most of us take place value for granted at this point. There's all the digits from the original number, and each one of them is being multiplied by a power of 10. And there's kind of, sort of, a pattern going on with the exponent on 10 that's related to the idea of place value. And because I chose to do one that even had decimal places, you got into negative powers. And so when you start thinking about what we're actually trying to do, it might help you to have stopped and forced yourself to think about this way. Because, what we're trying to do is get down problems like, now this is more like what's actually on your homework, so to speak. When we're trying to do something like convert 8.2 kilo ohms to, let's go milli, to milliohms. Well, because it's kilo ohms, that's 10 to the third. Because this is milli, that's 10 to the negative third. So if you think about it, you're really going from kilo ohms to ohms to milliohms. And because of the way that engineering notation works, which again, engineering notation is a form of scientific notation, this is your base units. So this is like to the 0 power, or just, it's not changing. Whereas this is 10 to the third power, so that you get over to 3 places and then a comma, because that's what it means. That's kind of like what we're getting at. Whereas this is, it takes 1,000 of these to even make a regular base unit ohm. So really, we have moved in terms of place value and just counting the decimal places in the number. We've multiplied by 1,000 or moved the decimal point 3 places to move from here to there. And we've done that again to move from ohms to milliohms. So we've moved, so to speak, a total of 6 decimal places. And then think about this. We're going from big units to small units. And so this number has to get even bigger. because for it to be the same as this, it's got to be an even larger number. So it's 8.2, and mentally we're multiplying that by 10 to the 6th. So it's 8.2, and we're going to move the decimal point 3 places. That would have gotten us to base units, and then 3 more places. That gets us to milli. And these numbers don't exist, so I just fill in some placeholder zeros. Can you hear my teenager playing Fortnite downstairs? He just yelled. And so our answer here with no commas is 8.2, and then 5 of the placeholder zeros, and then we start, and there would be a comma there, and there would be a comma there. So what had been this decimal point when we were working in kiloohms ends up being a comma. This part right here is from the fact that it was kilo and has been converted to ohms, but this part right here is from the fact that we then converted that to milli. And so again, from the other video or you're reading, you're remembering that like this is 10 to the 3rd or kilo. This is base units, or technically 10 to the 0. This is milli, is the prefix. So thinking of it as a power of 10, it's 10 to the negative 3rd. And so that's why the units all care about 10 as the base, because we work in a base 10 system. And even something like with place value, it's always about powers of 10. And then again, the reason why engineering notation cares about just the powers of 3 is because that's where the commas is. And so it's a convenient way to take big numbers and make them a little smaller by saying, well, it's kilo units, so it took 1,000 of them. Or if it's a small number and you want to look a little better, it's this. In practicality, you rarely are going to talk about this as 8,200,000 milliamps. What's probably more practical to talk about is the original 8.2, I said amps, sorry, ohms. The 8.2 kilo ohms. So that was, something you don't have to do on the homework, that I'm hoping helps just the concept make sense, plus sort of an extra example of how to do a conversion. You want to get down really the first few levels up and down the heart. You don't want to have to constantly look it up. If you look it up enough times, you won't have to look it up anymore. All right, I'm going to hope that that's good enough and stop this one.